Vasilis Zagkanas, application engineer. Today we are going to talk about how you can virtually test your own specific touch sensor patterns through simulation software field scale Sense. First, we will describe briefly how the projected capacitive sensors work. Then show you how Sense has simplified the simulation process. Next comes the main part of this webinar, that is to demonstrate how you can import your own patterns into Sense and solve the whole 3D model and get some meaningful results. Of course, we may ask any questions that you have during the Q&A session and get some useful information about how you can get a free trial of Sense. The project capacitive touch sensors consist of transmitting and receiving electrodes. The shape and dimensions of the electrode patterns are subjected to detailed research and development process. And there are many proprietary patterns out there, most often patented by the designers of touch sensors. Generally, electrode patterns may be placed at two separate layers, the double layer patterns, or at the same layer and get joined with bridges, with crossovers. Actually, this pattern is known as coplanar or single ITO pattern. But in true single layer patterns, there are no crossovers, although the transmitting and the receiving electrodes are again at the same layer. Metal mesh is a new entry in touchscreen industry. It can be used to create flexible touch sensors with high transparency and high conductivity, and can be found in both double or true single layer patterns. Now let's see how the pickup touch sensors work. Actually, between the transmitters and the receivers there is a mutual capacitance due to their coupling. The value of the mutual capacitance depends on the shape and dimensions of the electrode pattern and also the distance and the material between the electrodes. Now, in case that a finger or a stylus, of course, comes close to the touch sensor, it steals, let's say, some of the electric field lines. So the mutual capacitance between the electrodes is reduced. The controller that drives the touch sensor sends voltage pulses to the transmitting electrodes and gets them back distorted through the receivers. The change in the frequency of the voltage signal corresponds to a reduced value of mutual capacitance. And that's how a finger touch is detected by the controller. Now let's have a look in how touchscreen industry works. Research and development of touch sensors was traditionally done through prototyping process, which however is time consuming and also very expensive. Simulation, of course, is an alternative option, but simulation software in general was usually complex to operate and required expert users. This is the flow of the generic simulation tools. The touch sensor designers in generic simulation tools had to create the model geometry, then to apply the boundary conditions and generate the mesh, which is often a really difficult task. After the model was solved, they had to get the results and try to translate them into their engineering language. That's why we developed Sense, in which both the pre- and post-processes are fully automated. Regarding the geometry creation, we have a library of ready-to-use and fully parameterized patterns, so the entire 3D sensor model is automatically created. In addition, Sense offers you the option to import your own patterns. This will be demonstrated later in detail. Through an intuitive way, you can set up parametric analysis so as to examine the performance of the touch sensor for many, even hundreds different finger or stylus positions above the surface of the sensor. You don't have even to worry about the mesh generation or how dense it must be in order to get accurate results. This is done completely by Sense, either through predefined meshing options or through smart algorithms, which are based on adaptive mesh refinement. The simulation time is much shorter than competition, as Sense utilizes fast multi-pole method developed on the basis of boundary element method. And thanks to the fully parallelized solving algorithms, you can take advantage of multiple CPU cores available either in our cloud infrastructure or in your cluster and solve the model just in a few minutes. Regarding the post-process, the visualization of results is adjusted to the needs of touch sensor designers. The results are shown through intuitive capacitive maps and plots, which are familiar to touch sensor designers. The comparison between the results and the specifications of the controller allows you to check the compatibility between the sensor and the controller. Furthermore, you can export all the simulation results in either a CSV file format or use our export tool to create a customizable report in PDF format. Now Sakis is ready to show you the very simple process of importing and simulating customized electrode patterns into Sense.
Hello to everyone, and thank you for attending our webinar. Before showing you how the import process works, I have to show you a few ground rules that you have to follow when designing the DXF files used for the import. First of all, the imported pattern should be a 3x3 design, which means that it must consist of 3 transmitter and 3 receiver electrodes. Another rule is that each electrode group should be assigned to different layers. For example, the 3 receivers should be on a layer called, let's say, RX, and the remaining transmitters on a separate layer called, for example, TX. Also, the design can include the floating parts, which are basically infills or dummy conductors, as long as they are assigned to a separate layer. Another rule is that each entity of the DXF file should be a closed polyline and not just a connected line. You have to convert the line to a polyline. The current version of Sense supports the import of any double-layered pattern, including also metal mesh patterns and patterns with curved electrodes. I will demonstrate you 4 examples. We will create a DXF file from scratch, ready to be imported, and I will showcase you another 3 examples, one metal mesh pattern, another pattern consisting of diamonds and floating parts, and another one with curved electrodes. Excuse me. Now let me share my screen with you. Let's say that we have a DXF file that contains the whole sensor design. As you can see, this design is a design of a sensor that consists of 10 receivers and 15 transmitters. And we now have to make a few adjustments to this DXF file. For starters, let's create 2 separate layers. Let's name the first one receivers. And let's create another one called transmitters. Those are just basic operations that can be performed with any CAD software. Okay, as you can see, we don't need all those transmitter and receivers, so let's delete the majority of them and let's keep only 3 transmitters and 3 receivers. We have to slightly modify the receivers and the transmitters, and to do this, we first have to explode those polylines. As you can see, this entity is a polyline, and in order to modify it, we have to first explode it. This can be easily done by a command called explode. And let's select all of the electrodes. As you can see now, the electrodes are ready to be modified, and we can delete all the lines that we don't need. We have to create a closed polyline, so we will have to draw some additional lines. This is really easy. and you have to repeat this process for all the electrodes. Okay, now that we have a closed loop of lines, we have to convert those lines back to polylines. This can be easily done as well. Let's start with the transmitters. The software asks us if we want to turn this into a polyline. We click yes, and then we click to join it with the rest of the lines. Now you just have to be a little careful to select the correct lines, but this isn't too difficult. Hit enter, and as you can see, we have created the closed polyline. Now we have to repeat the same process for the rest of the transmitters. This shouldn't take long. Okay, this one is also ready. And let's do this one last time. Okay, so we have three transmitters, three entities that are closed polylines, and let's place them to the correct layer, which is the transmitter layer. This should do the trick. Let's confirm that they are placed there. Yes, that's right. And now we have to do the same process for the receiver. This time the process is a bit more easier because we can select multiple lines. That's it. Okay, and the receiver are also ready. Let's place them onto their own layer. And let's check that each layer is correct. Yes, we are ready. Now all you have to do is save it as a DXF file. Okay, let's call this one Diamonds Test. And save it on the desktop. And let's see now how we can import this DXF file into Sense. First of all, you have to navigate to the pattern section of Sense, and then on the scroll down menu, you have to select Custom Pattern. By clicking Create New, you open up the Sense Design tool. Basically, the Sense Design tool is the import module and the tool with which you can design your own patterns. We will click on CAD Import. At the time, we support the import of only double-layered patterns, but by the end of April, it will be also available to import the coplanar patterns, and on the next versions, you will also be able to import through single layers and whatever else you would like. Now let's open the CAD file. This is the one that we have created. And as you can see, the layer extractor recognizes the two layers that we have created, and it informed us that there are three entities in each layer. Now you have to assign each layer to the receivers and the transmitters, and just click Import. As you can see, Sense has imported the DXF file, and now you are ready to export it into an SDS file, which is basically the file that can be imported as a pattern into Sense. Also note that this yellow line represents the dielectric margins around the electrodes. You can specify this from the margins tab. And let's give this pattern a margin of 1 millimeter on the y-axis and 2 millimeters on the x-axis, and redraw it. As you can see, we have added a thicker dielectric margin around the electrodes. Now, by clicking export, we will create the SDS file. Let's save this on the desktop as well. And now move back to Sense GUI. By clicking load, you can load up the pattern that you have created. Now you are basically ready to set up the simulation, and Vasilis will briefly explain it later on, the different options that are present in Sense. Now just bear with me a little while longer. I will show you another 3 examples. We won't create them from scratch. I have created them earlier, so as to save you some time. Let's open up the diamond with the floating parts. Okay, so there's a lot going on right now. Let me turn some layers off in order for you to understand what we did here. As you can see, those are the receivers, 3 receivers, and with yellow, those are the floating infills or the dummy conductors that are present. And the same holds true for the transmitters as well. Let me show you those as well. You can see 3 transmitters and floating parts. You have to follow the same process as earlier in order to import it into the Sense GUI. First of all, click Import, CAD Import. Open the DXF file. As you can see now, we have more layers because there are 2 additional layers representing the floating parts. You have to assign layers again. And just click Import. As you can see, the image is a little bit crowded right now, but you can toggle visibility on and off from this button, which says Show. If you uncheck it, you can turn visibility of those entities off. And now you can review your pattern if it is correct and if the design has any flaws. And you can do the same for the receivers as well. Now let's click Export and call this floating. And then you can just load it up in Sense again. Okay, let's see now a metal mesh pattern. Metal mesh patterns are a little bit more demanding, but we handle them quite easily. As you can see, this is again a 3x3 pattern. Let's import it into Sense. As you can see, this is a quite dense mesh. You can see each electrode has been imported correctly. Now the process is again the same. You just click Export and save it as an SDS file. I can demonstrate this again. And now you can proceed solving the metal mesh pattern and setting up your dielectric stack-up and figure positions and so on. Now let me show you the last example of a pattern which has curved electrodes. As you can see now, the CAD layer extractor says that there are more entities present. This isn't a bug or a problem. It's just the way that the DXF was designed. Sense will stitch those entities together and create the 3x3 pattern. As you can see, again, the pattern consists of 3 electrodes, 3 transmitters, and 3 receivers, with curved lines. And by now, you already know the process. Just click Export. Let's name this curved. And let's open this up from the load button. And that's basically it. I think it's a quite simple process. It doesn't take up a lot of time. As you can see, you can create any DXF file in less than 10 minutes, let's say. And now I will give the microphone back to Vasilis. He will talk a little bit about the Sense GUI and how to set up a simulation.
Thank you, Sakis, for the presentation about the import tool. Actually, I'll show you now briefly the process that one has to follow in order to get some results. So once the custom pattern is imported, here these values ST and SR define the dielectric margins around the electrodes, and these numbers 8 and 6 millimeters in this example actually define the cell size, the unit cell size. So firstly, the user has to set up the analysis type. For example, the sensor may be a mutual or a self-capacitive one. Or we could hold on the smartphone, for example. In this case, it's an Earth model, or maybe it's left on the table. So here we have to select the floating model. Through Sense, the user can check the compatibility between the touch sensor and the controller. That's why we have included in Sense a library of several commercially available controllers, which differ, first of all, in the number of the transmitters and receivers that they can support. Actually depends on the size of the sensor, and the range of the capacitance that they can support. The most important specifications here is the sensitivity of the controller, that is the threshold, the minimum value of the change in the capacitance, which can be detected by the controller as a finger touch or a finger proximity effect. So, in order for the 3D model of the sensor to be designed, to be created automatically, the user has next to define the layers in the stack-up. Actually, this is the cross-section view, the side view of the touch sensor, where the user can add or remove a layer of the stack-up and change the position of the transmitting and receiving electrodes inside it. You can change the material. For example, you may have a glass on top of the touch sensor, and of course you can decide insert the thickness of each dielectric layer. So here you define the materials from top of the touch sensor to its bottom, where a grounded plane, maybe for shielding purposes, may exist. What comes next? The user has to define if they want to have results about the resistance of the electrodes. These results are very important for the designers of touch sensors, since together with the capacitance, it defines the charge time of the touch sensor, the performance of the touch sensor. So here the user has to give the value of the seat resistance of the transmitting and the receiving electrodes respectively. What is the most important feature of Sense is that the user can set up very easily a parametric analysis regarding the performance of the touch sensor for several, even hundreds different finger positions. So the user has simply to define the start and the end point of the finger movement along each direction, the Z, X and Y direction, and of course to define the step of this finger movement. Of course, we can get results for different simulation nodes, if it is central, edge, or a corner node, and change the dimensions of the pointer, if it is a finger or a stylus, for example. So once the simulation is set up, I'll show you the results by loading a solved diamond double layer pattern. These are the results of sense. Here you can see the sensitivity of the controller as defined earlier by the user. And this is the value of the mutual capacitance between the electrodes without any finger presence. Here we see the values of the resistance, the resistance of one unit cell of transmitters and receivers respectively. This heat map shows the simulated 3x3 electrode array. Actually, it shows the change in the mutual capacitance for several different finger positions above the surface of the screen. Each square here represents the different finger position, and each color shows how much the mutual capacitance is reduced for this specific position. For example, where we're just above the center of the node, we have this reduction in mutual capacitance. It's about 51 femtofarads. But at the corner of the node, this reduction is much smaller, and it is depicted by the blue color here. Of course, the heat map may give different quantities regarding simulation results of capacitance and resistance of the touch sensor. And what is very useful for the touchscreen designers is this filtering option. With this option, the designer can exclude from the heat map the squares which correspond to finger position which which cannot be recognized by the controller. Actually, this square here, the change in the capacitance is below the sensitivity of the controller. That's why they are not shown in this heat map. Later on, here we can see a plot of the mutual capacitance versus the distance between the finger and the surface of the screen. It's shown by this red line, red curve here. And we can easily understand that when the finger comes close to the surface, the mutual capacitance reduces. And the designer can have a very quick answer if this whole variation of the mutual capacitance is within the limits given by the controller specification. Actually, in this case, the mutual capacitance is below the range of capacitance that can be detected by the controller. So this controller is not compatible with specific touch sensor. And again, we can have different results here shown in the plot regarding capacitance and resistance results. What is also very interesting is that you can have an automatically created PDF report which gives you briefly the most important inputs and outputs of the simulation. You have all the information included here. First of all, regarding the analysis type, the controller, the pattern, which is also shown schematically. The same applies for the stack up, the pointer position, the parametric analysis, and of course the results with the heat map and the capacitance plot. That was a short description, a short presentation of sense and about how you can simulate your own proprietary patterns. Now we'll move on with our presentation, and we are ready for the Q&A session. Now it's time for you to type any questions you may have in the chat box. We have a question regarding the simulation time of 16 different finger positions. Actually, what is true is that simulation time depends on the dimensions of the simulated model and, of course, the shape and dimensions of the electrode patterns. For example, for a typical diamond double layer pattern, when we take advantage of our cloud infrastructure and simulate in 256, for example, CPU cores, we can solve 16 different finger positions in about 6 minutes. Is there any other questions from your side? I'll give you a couple of minutes more. Oh, there is also another question about how we can, if we can simulate the glove touch. Actually, this is a feature that is requested by many customers. So yes, we are going to include this feature in our very next version of Sense. Actually, it will be released at the end of April. So in about a month, we will be capable of simulating the glove touch. I will give you a couple of minutes if you have any more questions.
On the meantime, there is a quick poll that we would like you to answer. If it's not too much trouble, we would be greatly grateful.
So the first question asks if you use any simulation tool in your production team or your R&D department. The second is about your job, your company's target, if you design or manufacture any touch sensors. The third question, do you use proprietary patterns or some public ones, for example, Diamond or Manhattan? The other question is about how do you decide the dimensions and the shape of the pattern and the materials that you use in your sensor, or you follow the guidelines from IC makers. And the last question is about this webinar that you just attended. I think, I suppose we are done now. So, I think we have one more slide on presentation.
Yes.
It's about how you can get a free trial and try the capabilities of Sense on your own. Of course, we could arrange a dedicated demo of Sense adjusted to your needs and have further discussions about your simulation needs. So thank you for your attention and for your time for attending.
Thank you for joining. And,
we hope see you again in our next webinar. Thank you again. Goodbye.
Bye-bye.